Hi, I'm Michael Whiteman. I'm the product manager for HBK's range of handheld sound and vibration measurement instruments. I'm here with the new Building Acoustics kit for 2255 outside our Copenhagen office. So let's go inside and do some sound insulation measurements. Today, we're going to measure the sound insulation between two of our meeting rooms. Now, this measurement situation is a little bit unusual. Ordinarily, these measurements are done near the end of construction, before the building is furnished and occupied, and often before elevators work or the floors have been finished. Most of the time, you would measure several partitions in one day, so you'll be carrying your gear around a lot, so you really appreciate having gear that's lightweight and robust. And because the floors might not be finished and the elevators might not work, you want to be able to carry it and not have to roll it. So a flat case might not be the best solution. Okay, so we've arrived at the rooms we're going to test. This room will be our source room, and this room will be our receiving room. And at the end of the test, we'll know how well this wall is preventing sound from being transmitted between the two rooms. Here I have our Type 4292L OmniPower sound source. The L stands for lightweight. This one's only 8 kilos, but it's just as powerful as heavier sources. There are some lighter sources on the market, but the devil's in the details. Often they can't maintain high levels for more than a few seconds, and they're not well protected from dust, and they're not very robust for use on a real-world building site. So let's go set them up. So now it's time to set up our amplifier and our sound level meter. But first, let's have a look at our backpack here. So this contains everything we need for our survey, except for our sound source and its tripod. It even has straps for the tripod for our sound level meter. There are some interesting details on this backpack. Like I mentioned before, often when we make these measurements, it's on an active building site, and the floor can be dusty and covered in debris. So one of the nice details here is when I open the backpack, you can see the side with the straps doesn't touch the ground, so my back's not going to get dirty. Here's my HBK 2255 sound level meter. Just like 2245, it's lightweight, grippy. I can easily reach all of the buttons with my thumb while I hold it. And this is our first HBK branded sound level meter. I also have our new power amplifier, the HBK 2755. This has exactly the same power output as our old 2734, but at 2.2 kilos, it's around about a third of the weight. It also has integrated Wi-Fi and Bluetooth and a powerful signal generator. So I'll go and set this up now. Okay, so most measurement standards require that we calibrate our sound level meter before and after each series of measurements. So let's do a quick calibration check. Now, just like on 2245, 2255 will automatically recognize the calibrator tone and start a calibration check. As expected, the check is passed. So now I'm ready to set up the sound level meter in the receiving room, and we can start our measurements. Just like the apps for 2245, we can attach photos, videos, and voice and text notes to our projects. This is really useful on building projects because quite often when we're doing the survey, we could notice things about the room that are going to affect our results. So maybe we'd find a sloppy penetration, or maybe the door seal isn't well installed. There's no defects that I can see right now, but I'll just take a photograph in the corner here to demonstrate the feature. So now this photograph is attached to my measurement project, and when I look at this later on the PC, I'll have a record of what I saw on site. Now that my equipment is in position, I'll close the doors. Now we're ready to start measuring, so I'll start the Building Acoustics Partner app. As you can see, the app has detected my sound level meter on Bluetooth, so I'll just touch that and connect. And I have a project that I made before for HBK Copenhagen, and this project has the geometry of my rooms configured already, and also all of the settings for the measurement standard. There are a lot of different standards and a lot of different ways you can measure, so I won't go through all of the settings right now. We'll just jump straight into the measurements. Now, I've set this up as a planned survey, and when we do a planned survey in this app, we can have an order of the different types of measurements. I've used the default order that we have, which is the background measurement first, then the level in the receiving room, followed by the level in the source room, and finally the reverberation time. We choose this as a default order because it lets you see any problems you might have overcoming the background sound as early as possible in the measurement process. So you can see on the app, the measurement assistant is asking me to move the instrument to position 1 to measure B2 position 1. We already have that set up, so I'll hit OK, and now we'll start the measurement. So you can see while I'm measuring, I have a spectrum at the bottom, and at the top I can see the profile for each frequency band. We made this inspired a little bit by old level recorders on paper, so you can see the level drawn across the screen as you go, and this helps you to see if there are any problems with disturbances, so you can see visually on the profile what's happening. But we didn't have any problems on this measurement, so I'm going to hit the tick and accept it. So now the measurement guide is asking us to go to L2. We already have the sound level meter in the receiving room, so we're ready to measure L2 right now. So I'll just hit OK, and we'll start this measurement, and this time the loudspeaker will start. So now you can see that the level we're drawing on the screen is much higher than the background level. And I think you can also see that it's a lot more stable because it's just noise from our loudspeaker, which is very stable, and not the affected so much by the ambient sounds in the space. Okay, now that that measurement's finished and I'm happy with it, I'll hit the tick to accept it. And now the guide is telling me to go to L1. And for this, I need to move our sound level meter into the source room. So I'll do that now. So the standard we're using, ISO 16283, allows us to make our measurements in several different ways. You can measure with the sound level meter in your hand or on a tripod. The operator can be inside the room or outside the room like I am now. You can also have fixed measurements or measurements where you sweep through a particular path. There is a reference result, however, if there are any disputes. The reference result is measurements taken with the operator outside of the room, like I'm doing right now. So let's measure L1 now. So we can see on the app that we have a higher level again in the L1 compared to the L2, because, of course, the sound from the loudspeaker no longer needs to go through that wall to get to the sound level meter. That measurement looks good, so I'll accept it. Now the guide is giving me a choice. I can go back to L2 when I move my source, or I can measure the second source position of L1 again. I'm going to measure L1 source 2 so that I don't need to move the sound level meter. Now, according to the standard, the two source positions must not be parallel to any plane of a boundary in the room. So I need to change the height of the loudspeaker. And then I'll also move this a little bit further away from the side wall. For these measurements, I'll do this as a scanning measurement. So I'm going to take the sound level meter off the tripod, and we're going to attach our microphone extension rod. There are 4 different scanning paths in the ISO 16283 standard, but most of the paths require that you change your foot position while you're measuring. There is one path, however, the cylindrical path, where you don't have to change your footing, but that requires an extension. So that's why we have this rod. When I make the scanning measurement, I'm going to be inside the room with the loudspeaker. So the levels are quite high and dangerous to my hearing. So for this, I'll wear hearing protection. For this measurement, I'll also control the measurement on the sound level meter instead of the app. I have the app in a special pocket mode in my pocket. So that's all of my L1 measurements done. So now I need to do one more level measurement in the receiving room. And because of the wall, the levels are safe, so I don't need my hearing protectors. For this measurement, I'll also take the app out of the pocket mode so you can still see what's happening on the measurement screen. So now we're finished with all of our level measurements, and we just have one type of measurement left to do. And that's a reverberation time measurement, which we're going to do in the receiving room. The reason we do this measurement is that normally when we're doing a sound insulation test, this room is not furnished and it doesn't have any carpet. And that means that the acoustical absorption in this room is much lower than it ordinarily would be when it's occupied. And that will mean that the levels that we measure in here are higher than people who are using this room will experience. So we make a reverberation time measurement, and then we can correct our results to simulate what this would be like with typical furnishing. So for the reverberation time measurements, there are 2 different methods that we can use. One is to use interrupted noise from our loudspeaker. An advantage of this is it doesn't require any additional equipment, but it is a little bit slow. So what we're going to do this time is make a measurement with an impulsive noise source. This can be something like a balloon that you blow up and burst. There's also some clapperboards. But what we're going to use is a starter pistol. This is the most popular way of doing it. Except for that it can have some problems with permitting in some countries, but it's definitely the fastest way. So again, for this measurement, this is potentially dangerous for my hearing, so I'll put my hearing protectors on. I'll leave the app open here so you can see the RT measurement as I make it, and I'll go and do a single decay. If we were doing this according to the standards, we'd normally do a minimum of 6 decays, but since this is a demo, we'll just stick with the 1. So now let's have a little look at what we can see on the app screen. So at the bottom, we can see our reverberation time spectrum. So this is the decay time in each third octave band. And then above, we can see the backward integrated decay for that particular band. If in any band, I could see that the algorithm hasn't correctly calculated the decay, I can actually adjust the slope by dragging these lines here. But this measurement looks pretty good. So I'll undo my edit and I'll accept this measurement. So now we've done all of the measurements we need for this test, so we can go to the result. So there we have it. We have our result, DNTW of 37. If I move the cursor around, we can see the DNT for an individual third octave band. And actually, I can see I have a quality indicator on 100 Hertz. So if I move the cursor to that band and then touch the little smiley, it tells me that I have a short reverberation time in that band. There's not a lot I can do about this right now. Maybe if I measured some different positions in that room, I could get rid of this, but I'm not too concerned. So I'm happy with the data. My client's a pretty impatient kind of guy. So rather than going home and loading this up to make a report, I'm going to send this straight to my colleague Thomas so that he can start working on this straight away. We want to keep this data secure, so I'm going to set a password. I'll just set HBK. And now the app is going to bundle that project up and upload it to HBK's cloud. Then it will give me a short link that I can paste into an email and send to Thomas. So I'll do that now. And that's sent. So I'm ready to pack up.
Hi, I'm Thomas Larsen. I'm a developer at HBK Copenhagen. So I'm working with Michael Whiteman, and I know that he has been doing a project where he has measured the sound insulation between a couple of rooms here in our new offices. And he's telling me that he wants a report quickly to Ben Bryson, and he's asked me to help him. So that's what I'm going to do. Let me share my screen. Go to my mail. See, I have one from Michael Whiteman. He has sent me a project through Asia that I can download, and then I can do a report for his data. So when downloading this, I see that there is a password protection on it. I happen to know the password, so I can open this. This is a mechanism that ensures that when users share data like this, that we cannot read their data. So that's nice for them. And now I have the project open here. You see I have the level measurements he did. He has made some nice measurements, it seems. He has a very high level in the source room, a lower level in the receiving room, and a low background noise. These are well separated. That means that it's probably possible to do some good analysis on them. I can see he's been a bit lazy, only done one per group here, but that's fine. For this experiment, it's fine. Here in the reverberation tab, I can see how his reverberation measurement has gone by, and I can see I'm very content with it. It's all very linear and nice, and there's no warnings except one. There's a yellow smiley here. The yellow smiley indicates that it's something I should look at, but not be too concerned about. And if I look at this in question, then I can approve of it. There's no problem there. I can see he has made an image here of some foot panel. So when he did his L2 task and his first measurement, he actually documented something about the room. That's nice. I will dig a little bit deeper, I think, just look at his raw data. Here I can see for each frequency how his time history is. And I can actually see that in his background measurement, there is some noise pollution. I assume that this is maybe Michael that has been a bit noisy. So I could, if I think that that is the case, I could exclude that from the calculation. And now the results will be groomed for that disturbance. So if I go to the result settings here, I can see what it all adds up to. It adds up to this, which is the insulation curve per frequency, and this, which is the frequency independent term. So this is actually what you want to make a report of. This is what the client is requiring. But to get at that point, there is a lot of different things that you can manipulate here. You can do different flavors of calculation, and you can select different standards. So each country will have their own. I'm on ISO 16283, which is widely used, so I'll stay on that. I'm happy with this result. So I can go to the report page and generate a report for Ben. So I can affect some things in my report. Some of it is given by the standard and the data, but other things I can affect, like here there's an empty field where I can put in a client name. I can just say Ben Horizon. And then I can also do other things, like for instance here, I can insert logos. I could take my company logo there. And then in the end, there's sort of when I'm done, I can sign this. I can either sign it textually just with my name, or I can use signature file. And here is then the final report. It's signed, there's logo, there's good data in it, and I can just ship it to Ben. I can either print it directly, or I can save it as a PDF, or I can save it as a Word document. So that's pretty much it. Then I've made the report, but of course now you're here. I wanted to show you that it's a bit more powerful than that. There's all these languages we have implemented. If I switch to Danish here, for instance, you see my user interface switches to Danish. Everything is in Danish, but you see my report is also Danish. If I did Excel exports, that would also be Danish. So that's pretty powerful. That makes this product truly usable in all languages, on all markets. One thing that is not visible in a in a project that's been done so quickly as this is how powerful the reuse concept actually is. You can see I have some settings here that allows me to reuse measurements. And if I just load a measurement we did, or a project we did in the old Building Care offices at NEOM, this one, then you can start to see where the true power of this product comes in. So if I'm in the field and I'm doing lots of different partitions that maybe have some rooms in common, then the software, instead of having to measure all these independently, it'll actually say that when I have measured these about 30 measurements I have to do for the first partition, then when I move to the next partition, it'll know what it can reuse. So for instance here, reverberation, all these reverberation measurements, it has just linked in. You can see here that it's linked from partition A to B. And as I move along all my partitions, there could be like 10 or 20 of these in the project, then it would save me hundreds and hundreds of measurements that it would just automatically know when it could reuse stuff and when it couldn't. So if I take a look at the result overview here for my partitions, I can see that the parameter I've chosen to look at has a target level that comes either from the standard or from some other requirement. And I can see how does all my partitions perform according to that. And I can have a quick pass-fail overlook of how does this all do? Is it up to standard or not? When I go to the report sheet, I can equally make a very quick overview here of all my partitions. It'll just generate these reports for all my partitions. If I go here and I do some setting here, like again the client, Ben, I'll just say, then it'll automatically change whatever I change here in all the documents. So that means it's very, very quickly for me to do like hundreds of reports for these hundreds of partitions. You see, these all now have the client Ben. So that's where the real power of this product comes in. That's when you have to do like realistic measurements with lots of partitions. You are saving a lot of time using this. Thanks.